My name's Sam Fletcher, Business Development Manager for Stiga UK. Stiga have invested significantly in the battery market to ensure you have the right product to future-proof your business. As well as these fantastic products such as the SAB 700AE blower, we also recognise it's important for you to have the right support in place for these products. So today we're going to discuss the diagnostic equipment that supports our 500, 700 and 900 series battery machines. Here we have a short overview of the Stiga battery and equipment diagnostic tool. You can see the part number for this diagnostic tool at the top of the screen in yellow. The diagnostic tool can be used with all 500 series, 700 series and 900 series machines and batteries. The diagnostic tool allows you extra power in diagnostic capability, allowing you to be more efficient and more profitable in the workshop, and also give your customer an extra value adding ability. Updates for the diagnostic tool are provided free of charge via Stiga Connect, and there is no software subscription fee applicable to this diagnostic tool. This diagnostic tool connects to a laptop or PC via a USB link. The diagnostic tool also allows you to generate powerful reports that gives you an extra line of communication with your customers. The diagnostic tool software can easily be downloaded from Stiga Connect. Simply go to the search bar at the top of the screen, type in diagnostic and hit search. Under the search results, select Documents and then select the Stiga Diagnostic Tool 500 series installer. Select any product that the diagnostic tool would be applicable to. Then follow the on-screen prompts to download the software. Once the download has completed, open the zip file and be sure to read the installation instructions provided within the zip file. Once the program has installed, you may find a quick link on your taskbar or an icon as a shortcut on your desktop for easy access. To use the diagnostic tool with a battery, follow these steps. First, connect the battery into the diagnostic tool. Then set the switch on the rear of the diagnostic tool to battery. Connect the USB lead of the diagnostic tool to the computer and launch the diagnostic tool software and connect with a battery. We now have our battery in the diagnostic tool connected to the laptop, and now we need to launch the software. Because we have only a battery connected in this instance, we're going to select Battery to connect. Allow the data to be downloaded into the diagnostic tool software, and now we can connect and view the data from the battery. We can see that this is a 500 series battery. We have the article number, the serial number of the battery, and when the battery was manufactured. We can also see the hardware revision and the firmware revision. We can monitor how much total energy has been delivered from this battery and how much working time this battery has undertaken in minutes. We can also see how much normal charging time has been undertaken and how much fast charging time has been undertaken. And we can even see when the last charging date was for this individual battery. We have data on how many individual working sessions this battery has and how many full charging cycles the battery has gone through. We can also check how many partial charging startups the battery has undertaken and how many times we have connected the battery to a fast charger. We can see the battery voltage here indicated in millivolts, the battery temperature, the battery full capacity, and we can see this is a 5 amp hour battery, and also the current state of charge. Note that both of these values are shown in milliamp hours. Across on the left, we can also see the state of charge across the individual cells. This battery has a good health. All of the cells have an even charge indication. If any error codes have occurred on this particular battery, we will see error codes indicated here. Major error codes will be highlighted in red. If error codes are presented, we can use the question mark button here to find some hints on what this means. The battery can monitor various error codes. Each error code means a different thing. We can have temperature-related error codes. We can also have voltage monitoring linked to error codes. Depending on what the error code is, you may need to advise a customer on changing their operating methods. For example, if we have a battery that constantly gives us a over temperature type error code, it may be that the customer is storing the battery travelling from one job to the next on the dashboard of a van, right next to a heater vent. We can also see that some error codes relate to individual cell balance in terms of voltage. If we have any battery cells that have a difference between them of 1 volt or more, this causes an error code to occur and the battery is likely to fail. Going back to the main dashboard now, and we can actually save data here. This data is not visible by you as a dealer, but can be sent to Stiga Technical for further analysis. We can also generate a report. This is a handy function that allows you to show the health of the battery to your customer. Once the report is generated, we can view the report and see some of this data. Once again, it gives us the serial number, the article number, and the production date of the battery, as well as all of the other data we saw on the previous dashboard screen. It also gives us the individual millivolts across the cells within the battery. Don't forget, we're looking for an even spread and a good balance across these cells, and we can see that this particular battery is in good condition. We're now going to connect to a battery that's not quite in such good health. Again, we'll select battery from the main toolboard. We can see that this battery is not in quite so good condition. This particular battery, again, gives us a good record of all of the details available on the previous screen, but we can actually see that this particular battery was last charged on the 14th of January 2020. We can also see that the cells on this particular battery have a lot less even spread of charge. In fact, around a quarter of this battery has a charge level that is over 1 volt in difference to the other cells. We can see also that the battery has an error code of error code 6, and that this relates to a cell balance failure. Obviously, we can see this indicated here. If we click on our question mark, it gives us an indication of what this error code means, and we can see that it's highlighted in red, meaning that it is a major error code. Error code 6 and a flashing LED on the battery or tool gives an indication that the cells balance have recorded a failure. This may be caused by too much time since a last charge or individual cell failure. But given that we have several cells that are different in voltage to around a quarter of the battery, it's likely that too much time since the last charge is the cause. We do need to check the functionality of the charger for this instance, as the charger not functioning correctly may well have been the cause of the initial failure. Going back to the main dashboard now, we can generate a report for this battery to hand to the customer to give some more detail of this failure and the reason for the battery needing replacing. On the report, we can see all of the data we've discussed on the previous dashboard page and what this error code actually relates to, why the battery has failed. It also gives us a clear record here for the customer's information on the last charge date. We also have a nice clear record here of the voltage level across the cells. This gives us a clear method to indicate to the customer why this battery has technically failed, and also we can then discuss what the cause of that failure may have been and how to avoid it in future. We can also see that at several points in the battery's history that this error code was actually triggered. This error code produces a flashing LED light, so at each instance of these error codes occurring, the customer would have actually been warned that this cell balance failure was starting to occur. As a technician, if you were to take this machine in at this point in time, and you can see that there are several instances of cell balance failure in the battery's history, it may be a good idea to monitor the battery cell level and ensure that all cells are a good balance, and if they are not, you can recommend to the customer that a replacement battery may be required in the future, instead of having the battery fail in the field and leaving the customer without a machine. We will now look at connecting equipment to the diagnostic tool. First, connect the fake battery into the tool. Then, connect the fake battery USB to the diagnostic tool. Set the switch on the rear of the diagnostic tool to tool, and connect a good battery into the diagnostic tool. Press the on button of the appliance and connect the USB lead from the diagnostic tool to the computer. Launch the diagnostic tool software and connect via the tool button. We're now going to connect to a piece of equipment. Once again, we can see data regarding the manufacturing date, the serial number, as well as hardware and firmware revision for this piece of equipment. We can see the total operating time in minutes, and we can also see some error counters signified here. The error counters relate to error codes, in the same way that the battery codes were generated. The last error code here we can see is error code 11, and that relates to supply voltage failure. Question mark or help button again can be used to diagnose these error codes. We can see here that error code 11 with a flashing LED relates to supply voltage failure and relates to, more accurately, under and over voltage protection systems through the circuit board. Normally, this is caused by abnormal supply voltage from the battery. So clearly, one of the most common things to be looking for is faulty batteries. For this particular piece of equipment, we know that that was the case, and we connected the faulty battery that we showed the diagnostic report for earlier to this piece of equipment. We can also see there are error codes for communication, error codes for ECU temperature related issues, as well as locked motor error codes. Locked motor error codes may be particularly useful for equipment such as brush cutters and hedge cutters. A large piece of branch stuck between the blades would trigger a locked motor code. The continuation of this code occurring may show that the blades, or indeed the motor, are binding continuously and would need to be addressed. The diagnostic steps to follow can be found in hints. Once again, it is possible to save this data and send to Stiga Technical for further analysis. But we can also generate a report to show the consumer the data generated from this data reading session. For equipment, total runtime, working sessions counter, alarm event counter, and last error code are all displayed within the diagnostic report. Also, we can see the work log from the diagnostic report for equipment. We can see this particular piece of equipment has 2 sessions, one for 5 minutes and one for 17 minutes. The first session at 5 minutes had an average amperage draw of 6.7 amps, but a peak amperage draw of 11.8 amps. The second longer running session only had an average amperage draw of 3.5 amps and a peak amperage draw of 5.3 amps, meaning that the second running session, although longer, was actually drawing less energy and the machine was being worked less intensively. Again, we're able to monitor the date and times for our error codes, and for equipment we can see our run history and our run current generated in a graph format. The top graph gives our session duration, with session 1 being 5 minutes and session 2 being 17 minutes. The second graph shows current, or load. We can see that the first session has a higher peak current and also a higher average current, whereas the second session has a lower peak current and of course a lower average current. So there we have the 500, 700 and 900 series diagnostic tool. Please note the hardware can be ordered using the part number seen on this screen in yellow text, and the software can be downloaded from Stiga Connect.